Alright, so here we are with Unit 6, Lesson number 3. And these are just a couple of questions about the previous lesson. A substance begins to melt. What happens to the potential and the kinetic energy? Well, remember, during a phase change, the kinetic energy is remaining the same because it's being converted into potential. So during the phase change, which is sections B, C, and DE, the potential energy is going up, but the temperature is the same. The temperature of a substance refers to what type of energy, kinetic energy. How does the speed and space of water molecules compare when in a liquid phase to a gas phase? Well, when you go from a liquid to a gas phase, the molecules spread further apart and they're moving faster. Alright, so let's look at a cooling curve. Cooling curves are, of course, the opposite of a heating curve. So that if something is cooling, that means it's losing heat, it's getting colder. So energy is being released. Notice it's the mirror image of the heating curve. So if we go through this, you'll notice that it's the opposite. It starts as a gas, so you're taking something that's a gas, cooling it, and it's going to turn back into a liquid. So when something goes from a gas to a liquid, that is called condensation. Once it's all in the liquid phase, and you keep cooling it, it'll eventually hit where you see point D. It'll then go through another phase change, and going from a liquid to a solid would be freezing or solidification. And the last one would be solid. So it's literally, if you take the heating curve and make it a mirror image, it's exactly the opposite. And you'll notice there's a term on the right, deposition. That's the opposite of sublimation. I've only seen it once on the Regents exam, so my suggestion would be I would not worry about it. But you remember, sublimation is when something goes directly from a solid to a gas and skips the liquid phase completely. Deposition would be the opposite. It goes from a gas to a solid, skipping the liquid phase. But again, deposition I've seen once. Alright, so quickly run through these things. I'm just going to fill this in. So make sure that you have all of this down. Again, remember that kinetic energy is the same thing as temperature. So you'll notice that in sections A, B, C, D, and E, F, the kinetic energy is going down. That means the temperature is going down, it's cooling. Again, during these phase changes, constant, the temperature is constant. That means that the kinetic is being... I'm sorry, we'll leave it at that because they don't really ask that about the cooling curve. Okay, so that's the cooling curve. You may want to freeze it, pause it, so I'm going to go on to the next page. I'm sure there are probably questions, okay? As a substance condenses, remember condenses means it goes from a gas to a liquid. What happens to its potential and kinetic energy? Well, we said that potential energy decreases, but kinetic energy stays the same. What phase is a substance in when it has the highest kinetic energy? Highest kinetic energy when it would be in a gas phase, because that's when the molecules are moving the fastest. And last, how does the speed and space of water molecules compare when in a liquid phase to a solid phase? Well, when you're going from a liquid to a solid, the molecules are moving closer together and they're slowing down. And that is it for Unit 6, Lesson number 3, Cooling Curves.